Welcome grade 12s. Today we're going to be looking at population dynamics. We're going to recap a few of the basic principles that you need to know when studying it, and we're also going to be looking at some of the questions that were asked in last year's paper and showing you exactly how you needed to answer those questions. I'm going to start off by just pointing out a few important points that you need to be able to study. It's almost like a checklist or objectives to make sure that you're able to understand those concepts, because the chances are they are going to be in the exam. The first one that I would like you to is the interpretation of data. And when I talk about tables, graphs, and pyramids, go back into your books and you should find your S-shaped graph. Okay, you've got your J-shaped graph, all your different growth curves. All right, you have, there we go, sorry, you have got your all your different pyramids. I'm showing developing countries, developed countries. All of those are being able to use ways in which we can show trends in population. Okay, the next thing you need to do is all the terminology, all right? And that is when you need to have all the factors that are going to affect a population size. We know that the population size will increase or decrease. What are those factors? Competition, all right? Predator prey, all of those factors, density dependent, density independent factors. All of those, what makes a population increase, what will make a population decrease, okay? Also, you need to be able to know the population size. And we know that when we use our indirect technique, all right, remember if I say these, the quadrant method, all right, and the mark recapture method. Both of those, all right, you need to know a formula. So those are the things that you need to be able to do. Make sure that you are able to do them, all right? And because those are the learning things, and make sure that you're able to use the quadrant method and to be able to use the mark recapture method. It's not in today's paper. It wasn't in last year's paper. So you never know. Maybe it will be in this year's one. Also, you need to be able to understand the trends in human population, all right? We are growing. What kind of things, what causes the growth rate? What causes our the human population to decrease? And obviously, specifically looking at South Africa. Okay, we're going to start now with the first question, all right? And if you have a look, I'm going to go through the first question with you. The first question has got to do with the very first checkpoint that I asked you to make sure you know, and that is on graphs. Okay, here they're actually asking you to plot the graph, and all the information from that is coming from the graph that you have plotted. So it's very, very important that you understand how to draw the graph, because the rest of the questions are going to depend slightly on it. Okay? What you have below is a table. I'm going to read the question. The table below illustrates the data collected during an investigation to determine the changes in the population size of impala in a nature reserve. Okay, the table gives us information about what's going to happen to impala over a certain period of time. So that's the introduction. If we go to question 1, question 1 says you must use the data in the table to plot a line graph. All right, so very importantly, that tells you what kind of graph that you need, okay? It needs to be a line graph. The second thing, it must show the population period of the growth form. All right, already there, remember, start thinking J-shaped graph, your logistic shaped graph, all right, or your S-shaped graph, start thinking along those lines over a 10-year period. Okay, so now we start with the skill. So we've saved time a bit, and what I'm going to do is here is the graph. Okay, now I'm going to tick off the checkpoints that you should always have. Doing a graph is really nice, easy marks. Okay, let's start off. The first thing that you always need to do is you need to have a heading. And here you will see 1 mark for the title. And they told you what the title wanted to be. They said to you, it's the population growth of the impalas over 10 years. When you have your heading, please remember you must have your 2 variables. What was the one thing that you were looking at? Here, this is variable number 1. the population growth of the impala. What was your second one? Over time. The variable was time, okay? And they were specific about the 10 years. So to get that 1 mark, you had to have both of the variables in that, okay? Now we start with our axes. Now I want to just show you something that you can try and remember. Whenever we get to a table, guys, you must remember that when it's on the left-hand side, the very first column, that is what we call the independent variable, and the one on the right is the dependent. What does that mean? Independent, x-axis, right? Dependent, y-axis. All right, you don't want to get your axes confused because then your graph is going to be incorrect. So if we have a look, right, what do we have? Year on our x-axis, starting at 2000, ending at 2009. You must make sure that you use a ruler. When they mark your paper, they're going to have a ruler and they're going to make sure that that line is the same distance each one. All right, you can't just decide eeny, meeny, miny, mo. Right, make sure that your distances are the same. Also that your years follow. 2000, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Then your y-axis, your dependent, the number of impala. What do we always do? We must label our axes. They can't be naked, right? They have to have a label. That was years on our independent. That was our independent. Our dependent, we put the number of impala. Now again, you must choose a logical, all right, number sequence. You can't go 2, 7, 9, whatever. All right, have a look over here. What do we use? 10, 20, 30, 40, and we go up sequentially. Then you take, all right, then you take and you need to plot. Now remember, it's a line graph. At each one, use your ruler, all right, because it needs to be accurate. Because some of the things over here, you'll see, it doesn't go on 10, it doesn't go on 20. You're going to have to use your judgment, okay? So each time you use your ruler, you put your ruler. This was nice and easy because the axes are already gone. 2001, you draw a line, all right, and it's 10. That's nice and easy. I draw a line, and I see where it is 10, and I plot a point. At each one, you are going to plot a point, right, and then you take your ruler, all right, and you join the dots. Have a look. The majority of marks is going to be for plotting. Okay, so again, if you get the axes a little bit demarcated, all right, a little bit confused, they're not going to give you naught for your whole graph, all right? They're going to take off marks for incorrect plotting. If you do the incorrect graph, they're going to just take off marks for not having the correct graph, and that was just 1 mark. But you don't want to. You want to get your full 7 marks, okay? Now, going from this, now you've drawn the graph. The rest of the questions actually are going to, all right, come from the graph that you have drawn. So let's start. We're going to start with question 1.2. What type of growth form? All right, and you only had 2 to choose from. Remember, you had the J-shaped and the S-shaped, the logistic, all right, and the geometric. This shows, all right, we have a nice pattern going up, and then it starts to stabilize. So for 1 mark, it is I'm going to just put S-shaped, all right? You guys do have a variety of names, logistic, all right, that you may use. I'm just going to use the one that I'm most comfortable with. Okay, describe, now the next question, very important. Describe and one. One thing you must make sure of, whenever they give you a number, all right, and they write it in capital letters, they only want one answer, and they're only going to mark your first answer. So as soon as they indicate a number, it's very specific about, all right, what answer they want. They want you to describe one characteristic of this growth form. All right, if we have a look, what made this one different to the J-shaped one? And it asks you to describe the characteristic. And what was the most specific, all right, trait of this graph? And it's for 2 marks. And your answer is, all right, think about it. What happened? where it was slow, all right, slow growth in the beginning, right, same as my J-shaped graph, but what did I have? Most important, but then it stabilizes, all right, that is the most important word. It stabilizes, all right, it's constant, right, so you've got the graph, it gets there, and there, that is the most important thing. We get the stable. So you'll get 1 mark for slow. Slowly starts the growth in the beginning, right? Then it might, you can say maybe it will grow exponentially, but ultimately where you're going to get your 2nd mark, you must talk about it stabilizes or becomes constant with the carrying capacity. Right, question number 4, name the phase. Now here, be prepared for them to give you the graph, all right, as well. And when we came to the logistic shape graph, you know that they each had different phases. We had the lag phase, then you had the exponential growth phase, and then we had, okay, the stability, all right, and then we had a slight decline. But they're asking you, all right, name the phase from 2000 to 2002. Now, do you see how important it is that you're going to have the correct axes? 2000, 2002, all right, what is that phase? It is the lag phase. For 1 mark, they don't want you to explain anything. Just name the phase. Remember, be kind to your marker. Now it asks you question 1.5. Explain the pattern of growth. Now explain it. So for 2 marks, what do you see when it comes to the graph? First of all, when we look at the graph, we see very slow growth in the beginning, all right? So we've got slow growth. That is your 1 mark. Give me reasons why. There's a variety of things you can put there. Why is growth very slow in the bottom? The animals are immature sexually, all right? They're still young. What else? All right, the animals haven't acclimatized. No acclimatization. They want to settle down. They want to get into the routine of things. They just don't want to start, you know, immediately. Everything needs to settle down. No acclimatization. What have they got to do? They've got to find mates. All right, they've got to find breeding partners. So 1 mark for slow growth and 1 mark for giving the reason why, because they've asked you to explain. So explain means tell me why. So first of all, I know it's a lag phase, and tell me why growth is slow in the beginning, all right, and what are the possible reasons for that slowness, that low, all right, increase in very slowish or sluggish increase in my population growth. Okay, now my next question. Nice interpretive one. They give you a little scenario here. An eland population was introduced into the same nature reserve in the year 2000. Okay, so they're with the impala. The eland and impala feed on the leaves of the same trees. Now, what should you be thinking? All right, automatically they feed on the same leaves. My mind would be ting, ting, ting. I would be thinking competition. All right, competition. They're going to be competing for the same resource. But the last line gives us a bit of a clue. Adult impala are smaller. Adult impala are smaller and shorter. All right, smaller and shorter. So let me draw you a picture. Okay, so if I were to have a tree over here, here would be, and here's all these leaves over there. The impala would, I'm going to do I for impala, all right, would nibble on these leaves, and the much taller eland would on the leaves above it. Okay, now our mind needs to start shifting into another gear. So question number A, explain why the impala and the eland are not in competition with each other, although they feed on the same food source. Okay, there we go. Looked at our little picture, the funny picture of our tree. Why do they not compete? Very simpler. Now put that picture into words. The impala are shorter or smaller and eat the bottom leaves. There we go. There's your 1 mark. And the eland are larger and eat the top leaves. So because they eat the top leaves, they are using, all right, different parts of the tree. Which leads us to the very next question where they ask you, what is that type of competition named? All right, and remember it is, all right, partition resources. The partition of resources or partition of niche, anything like that. What are we finding? That in the same, can you remember all these terms that you had to look at? That when we have competition, sometimes animals, all right, are able to not compete with each other, but they're actually, all right, one finds one food source, one finds a different part, but within the same area, and they are actually able to cohabitat together without interfering with one another, okay? Partition, all right, resources. Partition, one has one part, one has the other, but they both are sharing, all right, the same resource and not out competing each other. Okay, nice question. I like that question. Question number 2, do you notice every single time some kind of data, be it a table or be it a graph? Okay, remember I also said this has got to do with the human population. Let's read the question. The table below compares the human population, all right, size of 3 different continents in a specific year, in the year 2000. All right, now we're going to be asked questions relating to the first one. Now, the very first question is, using the information in the table above, calculate. All right, for some of you, I think I'm included, when you start to hear the word calculate, all the numbers running through your head, okay? Relax. Calculate the percentage increase of the human population in Africa. All right, read you. They don't want all 3, just one particular content. Show all your workings out. If you do it in your head or you do it on a piece of paper and you just write down the answer, you're only going to get 1 mark. You need to show all of it. Okay, so let's go to our table. All right, and let's have a look what we need to do. Okay, calculate the percentage increase. So what do we have to do first? We need to find out the difference between amount of people that were born and the amount of people that died. So our birth rate and our death rate. So our first little math sum is going to be, okay, 45 minus 16. And if my math is correct, that will give me an answer of 29. It's like adding up your tests. What did you get for your test? And surely a test must be out of something. What is it out of? Have a look here. 1,000 per 1,000 people. All right. So what do we divide by? 1,000. We want to get a percentage. How do we get a percentage? We times by 100. Okay, now this one's quite nice and easy because if you forgot to bring your calculator, then at least you could have worked it out by yourself. 1010 1010. All right, so it's actually 29 divided by 10. And when we divide, we move backwards 1, and then your answer is 2,9 what? Units of measurement percent. Okay, so you're probably going to get a mark there. You're probably going to get a correct mark for your answer. And very important, please don't forget, it is percentage. They ask you to calculate the percentage increase. So you must put the units of measurement. Right, our question number 2. This was quite a tricky one, okay? It's tricky, but not so tricky. If the doubling time, all right, and I'm going to go back to our graph slowly. Right there, information there, they gave you the doubling time. Africa 24, Asia 39, and Europe 240. Okay? If the doubling time stays the same, states that information. In which year will the population size of the year 2000 double in Europe? All right, there we go. Which continent are we looking at? European. Let's go back up, all right, to our table. And what is the doubling time of Europe? 240. And they said it's going to stay the same. So if that, there we go, we've got the year 2000. All right, and if we add the doubling time, all right, 240, in what year? 2240. All right, there we go, your 1 mark. You don't have to show the calculations because they did not specifically give you those instructions. 1 mark. All right, those of you who don't like math so much, right, not too much of a scare. Now interpretation comes, all right, over this. Now they asked you to give 3, what did I say? When there is a number and it is in capital letters, they're only asking for 3. They are only going to mark the first 3. If you write down 6 and your first 3 are incorrect and your last 3 are correct, they are not going to mark it. Right? The marker's instructions are very clear. Mark the first 3 answers only. Okay, now give 3 possible reasons why the death rate in Africa is the highest. Right, let's go back and have a look at our different continents that they chose. Africa, Asia, Europe. What do we need to start thinking about? Developed versus developing countries. Africa is a developing country. So what is the reason, right, why we have such a high death rate? Okay, think of possible things. If we think of dependent countries, okay, there's a numerous amount. Lack of proper health care. All right, lots of people are going to die. All right, what else? Lack of access to medicine. All right, poverty. Not being able, all right, to feed. What else in Africa? War. All right, what else could we have? Corruption. All right, which would lead to poverty. Okay, what else can you think of? All right, what else can we think of? There's a lack of, all right, there's a lack of, how could I say, there's a lack of access, all right, to proper health care. I'm going to go back to the health care. All right, so that 3 answers, okay, of the possible. So think about lack of healthcare, lack of availability, poverty, crime. We can actually put there crime. All right. War in the country. Anything that will not enable the country to be able to be as productive as it should be. Okay. So there we go. You have been given the table. And from that table, it's called a data response question. You've been given the data, right? And you now need to be able to interpret the results. Please always remember that calculations is one of the skills that you're definitely going to get in your end of year paper. It could be in any section, all right? We could have had a mark recapture here as well, but we don't have. Okay, we're going to go on to the next question. Question number 3. And remember in the beginning, I said to you, one of the things you need to be able to interpret, right, are the pyramids. That's part of the data. Have a look at this question. It says, study the age-gender pyramids. We know that that's what they show below, representing, now we've just come from the previous question, a developing country. So one of them is a developing country and the other one is a developed country. All right? Both pyramids have been drawn to the same scale. That is very important. They're showing the same information. All right. If we look at this pyramid, what do we notice? We notice there's quite a high birth rate. All right. But what do we notice over here? right, both for male and female. Although there's quite a high birth rate, what do we notice? All right, lots of people don't make it. All right, we have quite a high death rate as well. So high birth rate, but we have quite a high death rate. And that would be leading to the question before that, the lack of access to healthcare, the lack of access to medicine, the poverty, not having a good enough diet, etc. Okay, so when we look at this, what do we notice? A broad base, lots of youngsters, but we don't really have, all right, it tends to decrease going older, so not too many of them make it to a mature stage. Okay, then let's have a look at pyramid number 2. What do we notice here? The birth rate is much lower. We have a much lower birth rate. All right, but what do we have? If we have a look over there, we have our population has a very low death rate. So because the death rate is quite low, let's start thinking the opposite, probably access to medicine, all right, access to healthcare, have enough money and able to afford those things. So already just looking at it, we can start to see, if we were to hazard a guess, I would then already say that this would be your developing, all right, pyramid, and this pyramid number 2 over here would be an example of a developed country. Okay, now let's see what kind of questions they ask us. All right, question number 1, Okay, it asks you, which pyramid, 1 or 2, represents a developed country? I'm going to go back quickly. All right, which one? And before we even looked at the questions, we could see that it was pyramid number 2. So all you have to do is put 2, okay, for your 1 mark. Now, the next question, very specific. Again, it gives you 2 instructions, right, that you have to follow. The first thing, tabulate. All right, before I even start there, I'm going to do that because I already get 1 mark for tabulating. If you do not tabulate when it is asked, they don't even read your question. They're going to put a line through it and give you naught. It's very important. If they asked you to tabulate, you must tabulate. Okay? Now again, 2 differences between pyramid 1. So that's our 1 heading. Pyramid 1 and pyramid 2. Now just by drawing in your table, all right, don't always need to draw the outside borders, but I will here. Just by drawing the table, you've already got that 1 mark out of 5. Okay? Now, what do they want? The differences between pyramid and pyramid 1 and 2, but they give you what they want you. Life expectancy, number 1, all right? So life expectancy, number 1, and number 2, birth rate. Didn't we just do that? If I go back once more to my graph, I think we already started looking at that. All right, developing, high birth rate, low life expectancy. All right, in my developed, high birth rate, and also, a low birth rate and a high, all right, life expectancy. Now, when you tabulate, you must compare apples with apples. All right, so pyramid number 1. That is my developing, okay? I'm just going to write that. Pyramid number 2 is my developed. So, without having to go back, pyramid number 1, life expectancy, low or a decrease, all right, in life expectancy, all right, or an increase in death rate. On the opposite side there, 1, 1. All right, you talk about life expectancy again. You don't change. Okay, pyramid number 2, increase in life expectancy. All right, there we go. 1 mark, 2 marks. So you now have got 3 out of the 5. So obviously the next one, birth rate. Pyramid number 1, increase in birth rate. And point number 2, decrease in birth rate. All right, 4, 5. There's your 5 marks. Okay, just by looking at your pyramids again, I'm going to go back to it one more time. All right, the information is here. Look at the ages. You should know it says their age, male, female. Okay, you can draw conclusions from that. Pyramid 1, lots, gets to less, lot more people die. Pyramid 2, although a smaller base, more people reach maturity. Okay, so when it comes to the pyramids, it's giving us a good idea, all right, what the makeup of my population is. Now, which leads us to question number 3. Give one reason, okay, why it is important for a country to know the age and gender structure of its population. All right, last year we had one, the census. And why did we need to have all this information? Planning, all right? Planning. And what does planning mean? Quite simply means services, all right? Service delivery. If the government knows, right? If the government knows what the ages and the genders are, it's then able, right, to provide certain services and knows exactly where those services are going to be needed. Is it in healthcare for babies, right? Is it in old age homes, looking after the elderly? That is what enables us to be able to interpret that information. Okay, I think it's time for a break now. Right, go and have yourself a little bit of coffee or some tea and a little break, and we'll be back just now. Welcome back, grade 12s. We're going to be carrying on looking at last year's November end-of-year paper, and we're dealing with the question specifically on population dynamics. And we're now going to continue with question number 4. All right, question number 4 was a reading passage, which I'm not going to, all right, go through with you. They are in the notes, but if you will see, okay, it's a question on the elephants, culling of elephants in the Kruger National Park. Now, before you read it, some people say it might be worthwhile to look at the questions first, all right? Have a look at what they're asking for you, so when you start reading the passage, that you can then pick out the important points. You might want to, when you read through it, go through a highlighter, right, mark the important points, but maybe reading the question first will give you an idea of the things that you're going to then need for this particular question. Okay, as I said to you, elephant culling in the Kruger National Park. Let's look at some of the questions, all right, that were asked on this one. Okay, first of all, number 2, you were asked to define, all right, 2 terminologies. The first one is culling, okay? And if you have a look at read through your passage, but you also should have an understanding of what culling is. For 1 mark, all right, the first thing you had to write was killing, because that is what it is, all right? It's the purposeful killing of animals. For your 2nd mark, usually the reason why. Why do they have to kill the animals? There's a variety of things you could have written for mark number 2. 1, to decrease the population. All right. Another one, why do we need to decrease? Because of habitat destruction. All right, they're destroying the environment, they're destroying the producers. All right, so they're having a negative effect on the environment, and that is why they are culled. So habitat destruction. All right, what else? What would be another reason why we would want to have them? All right, to decrease competition. All right, so when we're looking at culling, most important, it's the killing of animals, right, for a specific reason. All right, it's the purposeful killing of the animal, right, for a particular ecological region. Okay, carrying capacity. All right, very important. It is the maximum, all right, the maximum amount of producers Very, very important. That is your first mark. It's the maximum amount of producers, all right, that is found that can, all right, hold, let's see, maximum amount of producers that can ensure the survival of consumers. Right? So what is it? The carrying capacity, a certain environment has only got a certain amount of food. All right? And the number of animals that are on that specific area, right? The carrying capacity, the amount of food for that is limited. All right? Once we reach the carrying capacity, so if our population becomes too big, what happens? Our density dependent factors come in, right? Our competition for shelter, for water, for mates, all right? And what are we going to find then? Then we're going to find a decrease, all right? In our ecosystem, we're going to find a decrease in the numbers of animals that live there. Okay, now question 2, 4.2, quite tricky-ish, all right? What they are asking you for, let's quickly read through it. What evidence from the above passage, right, shows the following? It's like English where they ask you, all right, to use a quote, all right, to justify your answer. Okay, so what, if we're going to go and look through the passage, what evidence says that scientists are blaming themselves for the elephants damaging trees in the Kruger Park? All right, what it's basically saying there is the scientists recognized they'd made a mistake. Right, where in the passage does it acknowledge that they made a mistake? And I'm going to go through quickly with you to the passage. All right, and I want you to have a look, all right, over here. There we go. It's this point over here that we're looking at. And it's about the watering holes. Okay, trying to get it. There we go. Okay, what happened is they installed these artificial, have a look here, artificial watering points throughout the park. And they thought that if they put all these little watering ponds throughout the park, all right, that the elephants would be distributed throughout the park. But what happened is that it actually didn't. It caused the animals, all right, trees far away from the rivers became the targets of the elephants. So what happened was, instead of just confining them to one specific area, if they had just left it, so letting the elephants go down to the natural rivers and just using the trees there, okay, they put them all over. And in doing so, what they did, instead of just limiting the damage to one area, the damage was then all over the areas, okay? So if I go back to the question, all right, what scientists are blaming themselves for the elephants damaging? You go, you start your quote, and if I'm going to go back there, all right, this is the one, there we go. That is what you had to write. The installation of artificial watering points throughout the park has distributed the elephant population across the park. So it's the artificial water points that were the problem. It was incorrect to have done that. Okay? Question number 2, quite a tricky one. All right, you had to actually interpret. Now, number B, reading again. What is the next question is, we're going to go back there. Elephants are not the only threat to the reduction of biodiversity. So we go back to our passage and we're looking for not only are elephants, all right, a source of decrease, not damaging the environment. What is the other one? All right, and if we have a look over here, you're going to see right underneath it, there we go, the impact of global warming. All right, and what does it do? It suggests that many plants and animal species currently found in the Kruger National Park will not survive there within the decades. All right, so global warming could bring about a threat, because what is it going to do? It's going to decrease in biodiversity. All right, so global warming was your answer there, was the other threat. Okay, now, next question, if you have a look at the mark allocation, all right, 4 marks. And it asked you to give 2, you know the rule by now, first 2 answers only, and the word after 2, very important, explanation, all right, explanation. So you now need to give 2 explanations why some people would object to the culling of elephants, all right. So let's think of one objection, okay. Let's bring in the religious aspect. Okay, we don't kill God's creatures. All right, or God kills, that looks a bit odd there. Okay, let's go back. Don't kill God's creatures. Right, that's 1 mark. Right, explain your statement. All right, nature will sort itself out. Okay, you cannot just give why you think it's bad. All right, you can't just say like the next one, it's morally wrong. Right, you can't say that. Okay, the purposeful killing goes against nature's laws. Nature's laws. All right, so 1 mark for the reason, 1 mark for the explanation. All right, what is another one? That there is no conclusive evidence. All right, that culling, all right, that culling will stop habitat destruction. All right, 2, another reason. Okay, elephants have long memories. And because of that, the killing, right, actually affects the family. We're talking about the elephant family. Okay, so first 2 are marked. 1 mark for giving me, all right, the reason why you think people would object, and explaining to me what the reason for that would be. All right, so we don't kill God's creatures, reason being nature will then be able to sort itself out. Morally, it's something that is, all right, totally morally incorrect. The reason being, all right, that it's cruelty to animals, all right, and it causes stress, etc. So for each one, all right, the first 2. Now, if you give me a list of 3, that is where the marker stops, right over there, okay? If the ones at the bottom are correct, sorry, you need to be able to organize your thoughts and be able to put your best answers down right at the top, okay? As I said, 2, that was the magic number there. You had to give me 2 explanations. All right, let's go on to the next question. I like this question. It was quite trickish, all right, but I find it a nice, funky kind of question. It was really enjoyable to do. Okay, let me read through it with you. The growth patterns of 2 closely related species, A and B, that rely on the same food source, all right, were investigated. Same food source, bells ringing. I'm thinking competition already. Okay, just in the back of my head. At first, the 2 species were separated, okay? So they weren't in the same area. And then the 2 species were kept in the same habitat for the same period of time. So we had them, species A and B, separate in the beginning, and for us, let's say, a couple of days, and 7 days. Let's take 1 week. We then put them together and kept them together for exactly 1 week. Remember, it's an experiment. We want to make sure, all right, our variables are correct. In all cases, the organisms were provided with a limited food supply. All right, ring bells again, competition. Limited food supply, they are going to compete. If it's not with each other, with themselves as well. The results are shown on 3 graphs. Okay, let's have a look at number A. All right, species number A, very much lag phase, establishing, then growth, and then stabilizing. Very little, there's nothing else to compete against. All right, and number B showing pretty much a little bit more successful, all right, being able to increase a little bit more, but very much if we look at the 2 trends, it is almost identical when they are by themselves. And you have a look at the time period here, was for 5 weeks. Okay, so graph A, species A, graph B, species B, separated. So we don't have the competition. Now we're going to look at graph number C. Wow, all right. All of a sudden you see a different change. Species A continuing to grow, and species B, what do we notice? Oh dear, all right, it's starting to decline. So obviously not as successful as species A. Now let's interpret those graphs. First question, state the type of community interaction illustrated in graph C. Okay, now let's go back. It's competition, we know that. But it's competition between 2 different species. So what kind of competition is it? Let me just write that, do that again. I'm going to rub that out because I need a little bit more space. Okay, inter-specific competition. Inter, all right? Inter, not intra, inter. All right, here's species A, all right, which is different to species B. They are 2 different populations, and when 2 different populations compete, it is interspecific. If they were the same, it would have been intra. Okay, now question number 5.2. The first thing that you have to notice, again, mark allocation. It is worth 6 marks. That is quite a bit that you have to write about. But let's have a look at the question to see what exactly you need to, the pointers you need. Okay? Using the graphs A, B, and C to explain the growth patterns of species A and species B when separated. All right. So there we go. That's the first thing. All right. What do they want to know? First point. Tell me what happened when they were separated. That's the first one. All right, so in A and B, what did you notice? Then you must compare it. What did you see happening when they were put together, all right, in the same habitat? Okay, so let's start off with when they were, I'm going to go back to the graphs. All right. Let's have a look at graph A and graph B. Let's see what happened. All right. So, would you notice a definite trend? Let's go and put those trends into writing. Okay. So, when they were separate, there we go. What did we notice? Both of the species, both A and B, all right, increased in number, all right, until approximately 120. Let's have a look, go back, all right, let's go back again, the population size. So over the 5 weeks, all right, what did we notice? The one thing, when they were separated, both A and B increased in number to approximately 120 within the 5 weeks. All right, there is 2 marks that you had to. All right, that was, you had to say that. So what happened? We see both of them showing an increase. Now, for the other 4, we need to explain, all right, what is happening when they get to number C. Okay, I'm going to write it next to here because it's easier to have the graph, all right, next to me so we can able to interpret. Okay, so let's start. So we start off when they were, all right, when they were together. Right, now what started to happen? Let's start at the beginning. In the beginning, both, all right, started to increase slowly. All right, the reason being, what were they doing? Adapting. All right, and what was there? There was enough food. All right, but after 1 week, what do we notice? Species A was out-competing species B. Okay, so here we go. They both increase slowly because there is enough food, but after 1 week, all right, we notice that the species A, species A was out-competing species B, and what was happening to species B? All right, their numbers were declining drastically. Okay, all right, they both, you could also said, they both had periods of, now let me go there, of stability. But ultimately, what happened? Here we go, the other mark. But ultimately, okay, I'm going to just write ultimately. What happened? Species B decreased rapidly. Okay, so what have we done? Here, we've looked at, let's take it part by part. What happens in the beginning? They both are slowly increasing. They're adapting to the environment. Both of them have got enough food and both of their numbers are showing an incline. Then we have a look over here. Then what starts to happen? Okay, A starts to grow much faster than B. They both reach an area of stability. Okay, A is still growing faster than B. And then what happens towards the end? You have to say within the last 2 weeks, what happened to B? B's numbers decreased rapidly. All right, now we're going to look at the last question, all right, for today. And this is, okay, again, I said I like this question. There was a nice little bit of interpretive flavor going on here. It's now read the question. Explain again, tell how the growth patterns of the 2 species in graph C might change if more food is provided while they're living together in the same habitat. I'm going to go back to this graph again. Okay, now have a look here. Our whole concept was about competition, all right? Remember they said to you there was limited food available. So now all of a sudden, what do? We add more food. So now we take that competition away. So what's going to happen if we add more food? Correct, yes. Species A will continue to increase slightly because it's reached its stability. So it will slightly increase, okay? But what are we going to see here? This is going to be the most marked difference. Species B will also, because there's not as much competition for food, species B might also, there we go, let's get the pink back again, might also show an incline. But what is ultimately going to happen? We know that species A does outcompete species B. So it's just going to take species A longer to outcompete it. So how are we going to answer that question? All right, all of a sudden, both species A and B will increase slightly. They will. All right, why? More food, which means less competition. Okay, but there is a but. Species A will take longer to outcompete. It will ultimately, species A is the stronger one, to outcompete B. There we go, your 2 marks. That's all for today, grade 12s. I hope it was a productive revision for you, and all the best for the end of year exams. Bye-bye from me.